With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, an object A of mass 1 kg is projected vertically upward with a speed of 20 meter per second. At the same moment, another object B of mass 3 kg, which is initially above the object A, is dropped from a height h equal to 20 meter. The 2 point-like objects A and B collision and stick to each other. The kinetic energy is K in joule of the combined mass after the collision. Find the value of K upon 25. Hence we can say here, suppose these are our two masses here. So here we can say their, let's say, height is given to be in the question here as 20 meter. So they are separated at a height of, let's say, 20 meter. Now here it says the mass, this is A mass projected vertically upward. Hence the mass, let's say A is the mass thrown from downwards and this mass is B. A mass is thrown vertically upward with a speed of here as 20 meter per second, and the other mass here of 3 kg, let's say A mass is our 1 kg mass, and here let's say B mass here is our 3 kg initially above, let's say, object A and dropped here. So initial velocity of, let's say, B mass is 0 and A mass here is 20 upwards. Now at, let's say, some height, they both collide and stick to each other. So at this point, let's say they undergo collision, and after the collision we can say here they, let's say, combine, stick to each other. So this mass here is our, let's say, mass B, this mass is our mass A, and just before, let's say, collision, we can say here velocity of B here is in the downward direction and velocity of A is in the upward direction. So we need to find here the velocity of the combined mass, which will be our 1 plus 3, that is we have here as 4 kg, and find out its speed by linear momentum conservation principle. For that we need here VA and VB. Hence we can say here, let's say they will, let's say, collide at this point. Hence we can apply here the time after which they will collide. So we can say here by relative motion concept, we have here as relative displacement equal to, we have here as u relative into t, plus we have here as half of a relative into, we can say here, as t square. Hence we can say here, since in both the cases g acts downward, so relative acceleration will be 0, relative velocity will be 20 upwards as b is at rest, so 20 upward direction, time is t, and the relative displacement here is our 20 meter. Hence after 1 second we can say here both the bodies shall collide with each other. Now coming to find out the velocities of A and B, hence applying V equal to U plus AT. First of all, for A mass we have here as VA equal to UA plus, let's say, acceleration of A into time as t. Hence velocity of A can be written here as initial velocity as plus 20, acceleration as minus 10, and time as 1 second. Hence velocity of A just before the collision comes to be 20 minus 10, which is plus 10 meter per second. And in similar manner we can say here velocity of point B will be equal to, let's say, VB as UB plus AB into t. So we can say here velocity of B here will be equal to, UB here is 0, acceleration of B is minus 10, and time is 1 second. Hence we can say velocity of B here will be minus 10 meter per second. Minus here denotes it will be in the downward direction, as we can see here. Hence applying momentum conservation. So by momentum conservation we can say here, just let's say before the collision and after the collision, here since no external force acts on the system, so total momentum of the system shall remain conserved, which implies here initial momentum just before the collision will be our mass of A, which is 1 kg, into velocity of A, which we have calculated as plus 10, will plus, we can say here for B here will be mass here is 3 kg, velocity of B here is minus 10. So initial momentum just before collision is in minus y direction. Hence after the collision we can see here whole system moves. Let's say combined mass will move towards minus y direction. So final momentum will be 4 into minus v. So this gives us here, on simplification we can say as 10 minus 30, as minus 20 comes to be minus of 4v. Hence v comes out to be our 5 meter per second. So we can say here the net kinetic energy of the combined mass, which here is given to be k in joule, will come out as half mv square. Hence the net mass of the combined mass of the system will be 4 kg and speed we have calculated as 5. So this value comes out to be 25 into 2, which here is equal to 50 joule. We need to find the value of k upon 25. Hence our answer will be equal to k upon 25, where value of k we have here as 50 divided by 25. Hence this comes out to be 2. Hence we can say here the corresponding value of k here is equal to 2. Hence we have 2 as our final answer. So 2 is the answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.